How to replace a battery in an Oticon Connect clip. First, remove the itty-bitty, teeny-weeny back cover retention screw. You'll need a very small T5 Torx bit screwdriver to do that. Next, at the USB port end of the Connect clip case, use a knife blade to pry it open. While the combination circuit board and battery tray is still screwed to the front cover, pry the battery out of the tray where it is held in place with some adhesive. Now use your T5 Torx bit screwdriver to remove the two screws that connect the combo circuit board and battery tray to the front cover. Leave the front cover on while removing the yellow cellophane covering the soldered connections of the black and red wires coming from the circuit board on the other side of the combo circuit board and battery tray. With the soldered connections exposed on the battery, use a soldering iron to melt the solder and disconnect the red and black wires from the battery. With the old battery disconnected from the circuit board, you can now remove the circuit board. Without a wire stripper that would work with such small gauge wires, I resorted to burning off the insulation in preparation for the forthcoming wire extensions. Next, I cleaned off the wires with some fine emery cloth. The new battery is 20 millimeters wide and won't fit in the battery tray. The original Connect Clip 3.7 volt 200 milliamp hours battery on the left is only 17 millimeters wide, 4.5 millimeters thick, and 30 millimeters long. Good luck in trying to find a 17 millimeter wide 3.7 volt 200 milliamp battery that size. My suspicion-based opinion is the original battery is proprietary to Oticon in an effort to deny its consumers a right to repair their property. Sadly, this denial of a consumer's right to repair his or her property is increasingly a goal of many manufacturers. So I purchased the 3.7 volt 200 milliamp battery on the right on eBay. Unfortunately, though it's 4 millimeters thick and 30 millimeters long, it's 20 millimeters wide and won't fit in the battery tray without some middle finger to Oticon modifications to the tray. I removed about 1.5 millimeters from the button side of the battery tray with this particular shaped diamond rotary tool bit. Be advised that while working on this project, the oblong big button fell out several times. Be mindful of that so you don't accidentally lose it. Next, I changed to this cylindrical diamond bit for the next two modifications to the battery tray. The first of which entailed removing the series of little nubs on the opposite side of the battery tray to make even more room for the new battery. Bingo! The new battery now fits. This is the hole through which the battery wires connected to the circuit board pass through to the battery tray. I added extensions to those wires that will have heat shrink insulation covered soldered wire connections that will be too thick to pass through the existing hole. So I enlarged the hole a tad bit. These are my extension wires, ready for soldering to the battery wires connected to the circuit board. Here you can see me soldering with my head up my butt as I mistakenly extend the red circuit board wire with the black extension wire. Oh well, I figured just as long as I connected the new battery with the correct polarity, I could circumvent this embarrassing blunder. I finished the extension wire connections by heat shrinking insulation over the negative polarity wire that happens to be red because I suffer from head-up-butt syndrome. With the extended wires routed through the previously enlarged hole, I then soldered the positive wire from the battery to the extended but miscolored positive wire from the circuit board, and slid some black heat shrink insulation previously slid onto the wire over the soldered connection. After heat shrinking that insulation, I soldered the negative wire from the battery to the extended miscolored negative wire from the circuit board and slid some yellow heat shrink insulation previously slid onto the wire over the connection. Next, I snapped into place the front cover. After compressing the heat shrink coverings with a pair of pliers in order to flatten them and thus allow for closing the back case cover, I distributed the wires over the top of the battery in preparation for installing the back cover. Notice the blinking LED lights? That's a good sign, right? Oh, before you put on the back cover, don't forget to reinsert the two silver-colored screws that hold the front cover to the combination battery and circuit board tray. I didn't get a video of that, so let's make do with the video of removing the screws running in reverse. Snap the back cover back into place. This video clip is not out of focus. You've just been drinking too much. Gloriously, the combination on-off and mode switching button works for turning it off. The final reassembly step is to insert the itty-bitty, teeny-weeny back cover retention screw using the T5 Torx bit equipped screwdriver. A final test of the on-off and mode switching button shows it will turn back on the connect clip, and my subsequent use of the rebattery connect clip revealed it would also work for switching hearing modes and for Bluetooth connecting. Needless to say, I was orgasmic with delight that despite my major screw-up with the miscolored extension wires, it works flawlessly.